Hello everybody, and welcome also from my side to this IGARSS. That is a virtual one. I'm going to present a little brief overview on status and evolution of big Datacube standards and analysis-readiness on Earth data. So let us see. Actually, when it comes to the big data, these typically today still are the raster data, gridded data, whatever you want to call them, and datacubes actually are accepted as a cornerstone for analysis-ready data. Actually, it's not only analysis. It's also about being ready for visualization, being ready for fusion, and maybe more properties. Fortunately, for the big geodata, we do have standards in place. In OGC, we have the Web Coverage Service suite of standards, including the WCPS language for Datacube analytics. And in ISO, we have the MDA extension to SQL, standing for multi-dimensional arrays. So actually, everything is set pretty much, isn't it? Actually, we are on a good way, but we are not yet there at the Holy Grail. So let's see where we stand. By way of a background, I'm editor of the Datacube standards in OGC and in ISO, and heavily engaged in the European Inspire. So let's have a quick overview on the standards. In the OpenGeospatial Consortium, we find the notion of a coverage that captures multidimensional spatio-temporally extended data. The data model is the coverage implementation schema, CIS, which tells us how to represent a coverage, what information structures it contains, and also a few encodings. There are ASCII encodings like XML, like RDF, like JSON, but also binary encodings like netcdf, TIFF, etc. And then we have the Web Coverage Service, the WCS, which is the corresponding service model. This is a suite of components that starts with very simple subsetting and reformatting and goes up to WCPS as one component of it, which actually gives us Datacube analytics, as I mentioned briefly. This has been pretty much adopted by the European Inspire initiative that goes for spatial data infrastructure that of course also includes such data. And so, not surprisingly, we find the OGC service suite again, which is adopted and enhanced with a few specific items which however are conformant with the overall model. ISO also has adopted these standards. That is, specifically we are talking here in Task Committee 211, which deals with geoimagery, about 19123-1, which is an abstract model that is currently under development. It's a working draft. And 19123-2, which is an implementation model, and guess what? It is exactly OGC CIS 1-to-1. So actually we have a common consensus about such coverage standards, and that makes it easy for implementers and users. By the way, there is SQL MDA, which goes for domain agnostic arrays. You can just as well model human brain images with it, or cosmological simulation outputs. Some notes: W3C also has been working on that and is also in dialogue with OGC. They have established an RDF-based partial coverage model. They call it coverage, but mind you, it's incompatible with the coverage standards of OGC, Inspire, and ISO. So that leads to confusion sometimes. The Rasterman utility that we also use, that we build as a Datacube engine for space-time data, is reference implementation. You can find the open source tool at rasterman.org on the web. Okay, actually these are of course not implemented only by us, but actually you find the leading tools implemented in WCS today, from open source, map server, GeoServer, QGIS to proprietary Esri, so that is quite widely adopted. Here's a little bit of a fun fact in between. Inspire actually first had its own coverage model, which was deviating, but actually then the service model references WCS from OGC, and optionally also WCPS, that is also a component of Inspire. Okay, however, OGC WCS says, well, we are going to use OGC coverages. And so therefore, actually, the Inspire WCS references via OGC WCS also the OGC coverages, OGC CIS, which makes it simpler for implementers because, again, we don't need to implement any special solution for Inspire. What we can use, however, in the coverage extensibility mechanism is to have any sort of metadata, and that is exactly the hook, to have metadata of whatever kind you want. For example, the metadata set that Inspire defines. Okay, so now, analysis readiness. Where do we stand actually? We have the standards in place and they define how to deliver and how to process such coverages. Actually, they serve to encapsulate an archive structure so that I get high-level functionality instead of just access to single files and millions of them. However, the archive structure still determines performance. So, if you have a GeoTIFF archive and you want to do time series analysis on that, yes, WCPS gives you nice functionality for that. However, performance will still likely be disastrous, because, well, GeoTIFF slices just are not efficient for time access, for temporal access. NetCDF, on the other hand, is okay, and therefore some archives have started to reformat their data from GeoTIFF into NetCDF kubelets to better support time series analysis. Then there are other issues that sometimes arise. The SAFE format that is used by the European Space Agency actually uses a combination of different techniques, zip file to cluster such a scene together with its metadata. That means we need to unpack, and now it depends on the unzip tool how fast that is. It uses JPEG internally, lossless, but okay, JPEG performs a cosine transformation, a wavelet transform, and that requires additional CPU cycles to reconstruct a pixel. That all actually slows down. A little bit more of that and more details we have presented last year at IGARSS, so I would refer to that one for further details. So the coverage concept actually is a concise description of such a datacube, allows it, and if that service then is fast or slow, depends on the archive, depends on the software used, that's a different story. But basically you can do all the analytics. Now, for example, you can also do fusion of divergent data cubes, and that is something that analysis readiness does not address so much today. Actually, it still focuses on single data cubes, which is a good thing. So a data cube is homogeneous, so easy to handle. Actually, it also contains the information that you can combine different data cubes. These will naturally be divergent. I mean, SAR data is different from optical data and is different from DEMs, thematic data like land use, etc. The coverage knows enough that we can homogenize them into one grid, for example, and then we can combine them. That's possible. Currently that has to be done manually. So if you want to get everything into the coordinate system of A, then you have to reproject B into the system of A. That is something that you simply write in the equation, in the expression. It could theoretically be automated, and that's an interesting research step into the future. For now, as I said, you have to do it in the analysis expression yourself. Okay, and that's actually about what I can present here in that little time available. So Datacube standards are available. They are mature in several senses. They are conceptually proven in that there is a formal mathematical semantics behind the data model and the service model. They are also practically proven on petascale services, on federations of large-scale data centers, and we do have the specs in place for generic and specifically Earth data with the MDA arrays and the coverages. And fortunately, we find an alignment across OGC, ISO, and Inspire. They use the same concepts, the same standards, and that means we have to have only one implementation that greatly advances interoperability. As I mentioned, W3C currently goes its own way. Analysis readiness. Okay, Earth data cubes are homogenized and therefore they appear as a homogeneous data asset, having one grid, for example, having one coordinate system, etc. So it allows for a seamless walk through space and time, which greatly eases access and enables access also for non-experts. Datacubes, actually, the standards define the data homogenization. There are further standards that operate mainly on metadata. CARD 4L, for example, has a distinct emphasis on metadata. Queries you can write today. It goes from simple extraction to high-level analytics and data fusion. More automation is desirable, and that is an aspect for future research. Now, if you want to see the standards in action and want to play with them, there is a couple of interactive demos available. Here are the URLs. Maybe you want to visit them and try out one-dimensional through four-dimensional use cases, working with data, working with metadata, just to give you a feeling on how these data standards would work and how you can use lots of different clients on the same data structure on multidimensional data cubes. And that's it for now. Any further question, please don't hesitate to contact me. Thank you for bearing with me, and have a great IGARSS conference.